If you work for a company or you're consulting and you're doing data science, typically you'll start with a question that you want to answer or a problem that you're trying to solve, and then you'll start by looking for data that supports solving the problem or answering the question. However, what we're doing here is a little bit different because we're starting with some data sources that we think are interesting, and trying to find things that are interesting in the data that we can display. So the differences between, for example, let's say you were working for a bank and the bank wanted to build a loan system. You would start by asking a question: what data is available at the bank that I can use to build a system that will determine who should be granted loans and who shouldn't? So you start with a problem or question that you're trying to solve, and then you locate data sources that support solving that problem. Whereas here, we're taking a little different approach. We're saying, okay, well, a bank already has all of this data available in these different formats. What kinds of problems can I solve using this data? So when you're trying to find something interesting in the data, the first thing you want to do is figure out what's in the data. And there are some basic commands that you can use to get an idea of what's going on. And sort of the first thing you can do is, like, right here, I have a data frame. Let's go ahead and re-execute this. I'm going to open a connection to the server. I'm going to execute a SQL query, and then display a data frame that I have coming back. So I see that in this case, there are 3 columns. There's a name column, a year column, and a name count. And then I can also get some statistics. So let me go ahead and add a new cell after that. And then for this particular data frame, I might want to look at some different statistics. So the first thing I might want to look at is info. And I can say df.info and execute that. And what this is going to show me is a list of the columns along with how many non-null values there are. So I see there's 3 columns: name, year, and count. The type of the name column is object, and this could be generally a string, but could be an object. We see that there's a year column, which is float 64, but really, if you look at the actual data, that should probably be an integer. And then there's a name count column, which is also float 64, but once again, that should probably be an integer as well. So when we go to clean up this data, maybe one of the things we want to do is convert the type of these 2 columns from float to be integer. And then name, this is probably going to be a string for a person's name, so maybe we want to change the type of that as well. Now, another thing that I can look at is the number of unique values in each of those columns. And for now, I'm going to go ahead and add another cell. And if I want to see df.nUnique, and then execute that, I am getting lots of email today. We see that there's 3 columns. There's name, which only has 1 unique value because it's Mark in all columns. And then there's year. There's 100 unique values, even though we see there are 146 non-null rows. So what's going on here? Well, some of these years are actually going to appear more than once, and it's up to us to figure out why. Now, cutting to the chase, what's actually going on is that this query is returning data for both male babies named Mark and female babies named Mark. And so there's 100 years for male data, but only 46 years for female data because fewer babies were named Mark who were female. So that's just a little artifact of the data. Now, usually we won't know that until we do a little bit more exploring. So like one of the things that you might actually want to do is look at the actual unique values. And so let me go ahead and add another column here. And I'm going to go df, and then I'm going to pull out the name column. And then I'm going to look at the unique values for that. So df, sorry, pd for pandas dot unique is a function that's going to take a column of data and produce a list of the unique values. So here, there's only one unique value. If I go year, here are the unique values, and I see that there's the number 1915 through 2014 for 100 years. And then if I do count, here are all the different counts for each row. Now, this is a useful thing to do, but you probably want to do it for all the columns. And one handy way of doing that is you say dataframe.apply, and then you can apply a function to that, which is pd.unique. So what this is going to do is it's going to take the unique method that I was just calling and apply it to each of the columns of data. And so what I get is name mark, year, and then for shorthand it just gives me ellipses if the list is too long. And this is usually enough to see what's going on. And then name count goes from 13 and up. Now, that's usually enough to tell what you want, but we're going to want to do this for all the columns. And rather than creating 3 separate cells, one for each thing, what I really want to do is just have a function like explore that takes a data frame and does all 3 of these things, all 3 of these types of statistics, and displays the results. But now, if I do that, so let's, for example, write a function called explore, and that's going to take a data frame as input. And then let's do df.info, and then df, it's actually print a row of dashes with a \n for new line. And then let's go ahead and do df and unique. And then let's print another row of equal signs. And then let's do df.apply pd.unique. So this isn't quite going to do what I want it to do. So let's go ahead and define that function. And then instead of calling df.nUnique here, let's call explore df. And you see I didn't quite get what I wanted to get. So this info thing, it printed its results. So this is the info. But then nUnique doesn't actually print anything. What it does is it returns a value. And then if that's the last value returned by the cell, whatever the last value returned by the cell is, that's actually going to get displayed here. So bottom line is we didn't actually get what we wanted. If we wanted to display that, we have to print df.nUnique and print that. So I'm going to execute that to define the function, and then I'm going to call it, and here I get my info and my number of unique values, and then the unique values for each column. So for this one, let me go ahead and add a gender here as well. And now, if I explore df, I see that there's gender both male and female. And then if I want to explore it a little bit more, which I might want to do, I might want to say df sub, and then let's pick only the rows where df sub gender is equal male. And then from this one, I want to explore. So if I look only at the male rows, I see that there's 100 rows coming back, 100 distinct values of year, one distinct value of gender, and 94 name counts. If I change this to female, I see there's 46 rows where female babies were named Mark. And I can see the distribution of values here as well. So now I can also see for the name count for female babies, the minimum number is actually 5, and that's actually true for this data set in general, that it doesn't include rows where there were less than 5 babies with a particular gender given a particular name. So what do I want to display here? One thing to display with this data set is the popularity of the name Mark for male babies versus the popularity of the name Mark for female babies.